morning to everyone, and thank you for letting us come here and tell about our experience. We are going to tell you a little bit what we have been doing in Spain, inspired by the ideas of Ruth and Theo. And I feel like we are now in Waterharmonica Kingdom. We come from the outer colony in northeast Spain. And I work for the Consorci de la Costa Brava. It's a small water agency in the coastal area of Girona province. We provide services to 27 municipalities, and we deal with the different parts of the water cycle. We provide drinking water to 17 municipalities. We do biological treatment to 31, and we also do water reclamation and reuse. In fact, is there a pointer here? Yeah, this is the water that we import to those municipalities. The difference comes from the local sources, so it means that with the local sources there is not enough water, and that's why since 1989 we developed some efforts. We did a lot of efforts in order to try to reclaim and reuse the effluents that otherwise would be disposed into the sea. So over the years we have worked in different types of applications for reclaimed water. We started with the large irrigation users as golf courses, like the one that you have here, I think, that also uses reclaimed water. Later we moved to some other public beneficial uses such as aquifer recharge and environmental reuse, and that's where the Waterharmonica steps in, and that's our experience. And lately we are developing non-potable municipal uses. 3 municipalities already have specific network systems, which mean that the small volumes can be supplied to potentially high number of users. And reclaimed water has become, for those municipalities, a new municipal service. This is our constructed wetland system that we did in 1998 in Costa Brava. This is the Costa Brava community, which is mostly a touristic community, and this is the wastewater treatment plant that provides service to this area. All this area south of this river, Muga, this is a nature reserve, and the nature reserve had shortage of water in summer, and because the wastewater treatment plant was built here, they asked, can we recycle this water for nature purposes? And we did some research on the literature and found out that we had to remove nutrients in order to do that. And in order to reduce nutrients, we saw in the literature that people were using constructed wetlands. So we had our constructed wetland built, we had European Union funding, then we started to supply water with this low level of nutrients for the nature reserve. When Ruth came into the picture and visited us and saw what we had done, he said that it was a Waterharmonica system. And we didn't know it was such one, but we were glad that we had similar results with different approaches, but our ideas were more or less the same. So later, when I was able to visit some of the facilities you had done here in the Netherlands, I visited Texel, and that's Ruth's impression that you started with systems that had a lot of engineering but a little natural appearance. Instead, our system had maybe a lesser engineering degree but a much more natural appearance, and newer developments like Grau or Sorendong or whatever else you are designing now, it's probably kind of a mixture between both. Or it has the engineering part but also a more natural look. Well, we have done since then some work together, and we also established some mesocosmos lines in order to join our efforts to the research that was already being done in different parts of the Netherlands. Of course, when I was starting to get in contact with Ruth and Theo, and I was hearing about Waterharmonica and they were telling me their ideas, I also had to do some processing in my mind. What are they telling me about? What is this thing called Waterharmonica? And last year in a congress in Sevilla in southern Spain, I was asked to present Waterharmonica in Spain. And so I had to think, what did I understand Waterharmonica is? So I did a paper in which I tried to explain what was my understanding of Waterharmonica, and that's what I said. It's a well, not a conceptual idea only. Now you have a lot of facilities here, but what I said is a conceptual idea developed by Kampf and Classen to use constructed wetland system for polishing treated wastewater and provide a simultaneous nature enhancement. That was my understanding, maybe also because that's what we did in Empúria Brava. But for me, the important thing is this double goal. It provides water treatment, can be very interesting for European Water Framework Directive compliance, but also allows or provides ecosystem recreation and restoration and enhances local biodiversity. A very challenging and interesting idea for me. We usually have constructed wetland systems, and we know that the water comes out clear than it comes in, and all kinds of things happen in there, and all kinds of organisms grow. So it's kind of a black box. And this idea of that what is happening in the wetland can be decomposed in several different processes was also very challenging. And with the Mesocosmos, we were starting to study or to contribute to the study of the use of Daphnia reactors as a biological filtration step. That has been also very interesting for us because we have learned a lot. In the process all over these years, we also did some brainstorming. I think that this graph, you have it now in the report, but totally refined. This is our work at that moment in a piece of paper in a bar in Spain. This is the degree of engineering, and this is the degree of natural values. You start with wastewater. You need a wastewater treatment plan. That's a lot of engineering and zero natural values. But from the moment you have secondary effluent and you use polishing ponds after the biological treatment, you see some nature coming in, less degree of maintenance, less degree of engineering as well. You go to constructed wetlands, less maintenance, a huge increase in natural values, and finally, when you give this water back to nature, you hardly do any maintenance there because it's nature, but also you have, that's where you have your highest natural values. So for me, it's also a way to land a plane, softly landing a plane, you know, how to discharge this water back into nature, just a pipeline, so you compromise a portion of your river or stream, or you do it in a soft manner, so you gradually approach what the river already has. It's also very interesting and challenging idea, I think. Anyway, to summarize now a little bit, what we have done there in Empúria Brava, well, these Mesocosmos have been a unique opportunity for understanding those processes. It's more or less what would happen in a polishing pond, but seeded with cladocera or filtration organisms. We studied nutrient microorganism, micro-pollutant, and particle removal. We also did an assessment of what species we had in there, what was the richness of species, and also how to integrate these kind of systems in the landscape and the water cycle. That's more theoretical anyway. And we had active researchers from several fields. Chemical engineering, Professor Victoria Salvador is here with me. She's the Dean of the Faculty of Sciences of University of Girona, and she's been very active. Also analytical chemistry, ecology, physics, and microbiology. And for us, the Mesocosmos have been a living lab in the middle of a full-scale facility. So we could compare performance of the full-scale facility with these pilot plants. Sometimes picture is worth more than 1,000 words, though this is a visual impression of what we got with our Mesocosmos there. And this is what we have learned. Low algae growth in winter season, higher in summer, but the quality is very good, especially when there is less sunlight. Excellent removal of particles, less turbidity, increase of transmittance, and very interesting results in microbiology. After a 4-day retention time, removal of E. coli below detection level, but also Clostridium spores and somatic coliphages. Greater removal of micro-pollutants than in the technical treatments. We have other reclamation treatments, filtration, UV, chlorine, so different approach, but in terms of micro-pollutant removal, they are not as efficient as these systems are. And we also have seen that this now should be maybe assessed in a closed environment, because over time we had like a mixture of experiments. First, we started as biological filtration, but then because they were open, these systems were open, we had colonization of all kinds of microorganisms. So in the end, we ended up with a mixture of things that were too complicated to study anymore. Anyway, that could be a new development for us. So over these years, this kind of studies and this work and being exposed to these new ideas has been an inspiring and fruitful relationship for many people, including myself, but also students that had their master's work done, or visits, or talks at the university, and we even learn a lot about birds, as you know, one of the main hobbies for Ruth. And finally, my last one. What can be the new goals? Well, we have done this work, we have had all these people involved and producing interesting results, so now the question is how to go on with this. We have some ideas, some new challenges, and we think that we can keep on working with Dutch people. You have a lot of experience, much more than we do, but we are enthusiastic and willing to work some more, so why not any collaboration in the future with you? That would be very interesting for us, and we would be very happy if this would happen. Okay, so this is my presentation, and now I'm giving the floor back to Ruth, so he's finishing the presentation.